At the absolute limits of theoretical physics lies a state known as the absolute void. This is a condition devoid of matter, devoid of time, and entirely empty of context. But to finally build a universe, that perfect mathematical symmetry must be broken by a single point of distinction. This equation represents the Genesis operator. The Genesis operator is a mathematical function that applies a localized distinction to an infinite empty set. By executing this function, the absolute void is forced to yield a discrete, measurable output. The output consists of two elements: epsilon, known as the primordial magnitude, which dictates the smallest possible unit of existence, and the seeded state, representing the initialization of the universe's very first data block. Reality does not start with the spontaneous generation of physical matter. It begins with the establishment of a mathematically distinct context, a record carved from nothingness. Traditional physics relies on a substance ontology, assuming the universe is made of independent objects bouncing around in empty space. The topic ledger theory discards that model entirely. Instead, it argues that context precedes content. In this framework, the baseline state of reality is a field of infinite informational noise, called everything. Physical existence is generated by carving that infinity into bounded, quantized subsets called topics. A topic only exists because it has a specific context to differentiate it from the noise. To maintain its existence, a topic must continuously record its interactions. This chronological history of events forms an immutable sequence known as a ledger. This equation defines the resulting macroscopic reality. Reality is not a static container. It is the infinite union of all active, computable ledgers expanding simultaneously from the initial Genesis block. You and everything around you are the aggregate output of countless individual data streams, fighting to maintain their mathematical context. To see how these streams function, we can model the universe as a computational simulation. We start with the universal set, representing a state of infinite, unstructured data. The simulation applies the quantization axiom. This rule dictates that reality can only be generated by forcing that unorganized data into discrete, measurable boundaries. This diagram shows a topic navigating the simulation. At each tick, it records its state, leaving a permanent node and a forward vector. These lock into a directed acyclic graph, or DAG, a network flowing strictly in one direction, physically representing the topic's ledger. A topic has no physical substance independent of its history. Its identity is strictly defined by the chronological, irreversible chain of past states it has recorded. When the contexts of two highly active topics intersect in the simulation environment, they create a violent collision. The system cannot process two conflicting states in the same space, so it forces a resolution. These collisions function as game-theoretic negotiations. The opposing topics must wager their available resources to influence the final outcome, allowing the simulation to generate the next consensus block on the ledger. This Shapley value formula calculates phi, the marginal contribution of resources each topic stakes to resolve disputes. Stakes include kinetic energy, computing power, or ATP, the molecule cells use for energy. The simulation computes these inputs, permanently inscribing the definitive physical event onto the chain. Physical, biological, and social interactions are executed through the exact same mechanism, a computational consensus protocol weighing the causal stakes of competing contexts. This framework forces a strict redefinition of time. Time is not an independent dimension that passively flows in the background. Time is exclusively the measured length of a growing ledger. To calculate a structure's depth, we use the assembly index, quantifying the minimum steps required to build an object. The equation isolates variable AI, the absolute minimum consensus events needed to construct the topic, tracing its exact pathway back to the Genesis block. Time and physical complexity are mathematically identical. A complex object does not simply exist. It is an object that required a longer ledger of sequential negotiations to assemble. For new macroscopic structures to appear, they must extract themselves from the ambient noise of the universe through an all-or-nothing phase transition. This graph maps the critical transition threshold, balancing an entity's signal strength against required structural complexity. If the signal fluctuates below the line, data remains unstructured noise. The instant the signal crosses this threshold, the entire structure emerges perfectly intact, forming a new ledger. Reality does not fade in gradually. It snaps into existence, block by block, whenever a specific context successfully overpowers the surrounding entropy. Because the universe records its history on an immutable, single-direction graph, every prior state is preserved. This turns the history of the cosmos into a strictly computable data structure, enabling what is called forensic reality. If we introduce an anomaly into the present state of the simulation, representing a disease, a mutation, or a system error, the ledger contains the exact sequence of events that produced it. This diagram applies quantum retrodiction via Bayes' theorem, a mathematical framework updating past probabilities based on new evidence. The probability matrix sweeps backward along the chain, calculating the odds of each preceding collision to isolate the exact origin state that mathematically guaranteed the present anomaly. No event is ever lost. Every current physical state carries the precise mathematical coordinates of its absolute origin. Scaling up from individual collisions, this ledger mechanism defines the architecture of the entire cosmos. This Lagrangian equation details the kinetic mixing at the macroscale. A Lagrangian is a mathematical function that summarizes the total dynamics and energy state of a physical system. Here, it defines a coupling variable that manages the relationship between the universe's visible sector and its dark sector. The functions are strictly separated. Dark matter serves as the universe's hard drive, storing the immutable memory and stakes of past events. Photons act as the active processor, executing the high-energy debates and collisions of the present moment. The kinetic mixing variable acts as a firewall, ensuring explosive processing power from current interactions cannot rewrite the immutable memory of the deep past. This strict separation of past and present poses a final question regarding the nature of physical existence. If you arrange two entities to have the exact same physical properties, are they identical? This table highlights the difference between qualitative identity and numerical identity. Two objects can share identical physical traits, but cannot share the same ledger coordinates. Even an exact molecular replica built in the future is functionally distinct. Its causal chain is simply an isomorphism. An isomorphism is a mathematical mapping that proves two different networks share an identical form, even though they are constructed from entirely different underlying nodes. The replica is a copy of the path, not the original event itself. In a universe governed by topic ledger theory, entities are not defined by the sum of their physical parts. They are defined by their mathematically irreversible address on the universal graph. The universe computes its existence, building reality one consensus block at a time.